Hi, this is James from Mode Lighting, and in this video I'm going to be covering getting an install ready for programming. Okay, so on screen here I have a typical drawing of an eDIN Plus system. This is showing 2 panels and a few keypads and sensors. In this video I'm going to cover the more specific wiring and tests that need to be done on an eDIN system that may not be something you've come across if you haven't installed one of our systems previously. I'm not going to go into any depth on wiring DALI or wiring mains dimming circuits, things like that, as they are standard stuff. The backbone of an eDIN system is the MBUS network. That's all the little blue Cat5s that you will see within a panel, and that is also going to be the blue interconnecting cables that go out to the keypads and to other panels. So regardless of the size of your system, this always needs to be one long daisy chain. And any connections that are being done outside of a panel should be using a 4-core cable, MBUS cable, or the Belden reference of 1502R, which is 4 cores and 2 of the cores are shielded. Cable will have 4 colours, and usually we use the red for the A, black for the B, blue for C, and white for D. So at any one point in your install, there should never be more than 2 cables. If you end up with 3 at any point, it means you've created a spur, and that is not something that will work. So in this case, we can see that from this panel going out to the first keypad, and then from this keypad to the next panel, and then onwards and onwards. So as long as you've wired A, B, C, D in the right order at every point, this drawing would make a perfect chain. So the only other things over and above this is that the beginning of the chain and the end of the chain will require a termination. This is a 120 ohm resistor, and for the example on this, the sensor has a little switch on the back which says term. That can be turned on to get the resistor at the far end. The other end in this case will probably be into one of the modules, and then that would be a little blue tab that gets put into the port with both of those added in correctly. When you measure across the C and D terminals at any point, you should see around 60 ohms. If you're seeing 120 ohms, it means you probably have a break somewhere on that MBUS run and you need to find it. If you're seeing something like 30 ohms, it means you probably have too many resistors on. Usual culprits usually end up being something like the termination has been left on at the power supply. So if your resistance is measuring 60 ohms across all of that, that means you've probably got your MBUS run perfect. The last point would be that at the moment that would have power linked between the 2 power supplies, which is not ideal. We would really want to separate it out so that one panel powers one part of the system and the other panel powers the other part. To do this, you would have to remove the A terminal at the income out into the second panel here. So only B, C, and D would be connected. That would isolate the power to the 2 panels. Once that is done and any circuit tests are done, the system should be ready for programming, and the modules would need to be addressed at this time, along with all of the keypads and the sensors. Hopefully that gives you a brief overview. Thank you for listening, and please like and subscribe for more content.